So this photograph always reminds me of something I might have seen in the old Star Trek movies or the old Star Trek series, where we have some sort of nebula out there, some sort of mysterious gas. But actually, this is a photo we're going to look at later, and it is a photograph of a cluster of galaxies, and we're looking at that cluster in the X-ray region of the electromagnetic spectrum to try to get a fix on the temperature. But one of the things that we're going to see with galaxy clusters is that there is a fair amount of dark matter strewn between those galaxies. And actually, dark matter is something we talked about, I think, clear back in Chapter 1 when we talked about kind of the overall structure of our universe. We said that our sun is a member of the Milky Way galaxy, and the Milky Way galaxy has a fair bit of dark matter in the halo region. So finally, we get to talk about a little bit more about dark matter and dark energy. And just in case I forget to mention it, I do have a very, I think, pretty good playlist of these of related YouTube videos, and I would just encourage you to check that out. Dark matter and eventually dark energy. And I think I talked about dark energy maybe at the end or in a recent chapter about why our universe is not only expanding, but that expansion is accelerating, and acceleration must be due to something, and that something is dark energy. But dark matter and dark energy, they're dark not because, well, they're dark because we can't see them. They're dark because they're underluminous. And what we're going to see is a little bit disturbing, perhaps, to you, that if we look at our universe as a whole, and we have a pretty good fix on our universe, even from our perspective on this tiny planet around this typical star in this wonderful spiral galaxy. From our perspective, we can kind of, we know some of this stuff. And actually, this chapter, I'm not going to convince you why we know what we know, but I'm going to kind of tell you what we know in general, as this textbook was written. So matter and energy actually are interchangeable, according to Einstein. So we can look at the universe and kind of split it up. We can look at them as kind of being interchangeable. In that sense, the normal matter, now that would be like atoms making up you and me, and the gas you're breathing, and the planet we're walking on, and the star we're orbiting, that's all normal matter. Normal matter is about 4.6% of the universe, right? Most of that matter is, well, 0.7% of that matter is associated with stars, and 3.9% of that normal matter is outside of stars. That would be planets and nebula and that sort of thing. The remaining matter that makes up the, or I should say the remaining stuff in the universe, 23% is dark matter. And 72% of the universe is still energy, specifically it's dark energy. Now, one of the things that dark matter and dark energy have in common is, although we can't see them, they don't emit any form of radiation, they don't reflect any form of radiation. We can't see them, but we can see their influence on normal